My name is Javed Asghar. I'm here joined by Jacob Rapp and Maurizio. Today we will cover the secure enterprise data center, and the focus will be specifically on the Nexus Smart Switch and Hypershield integration. This is the solution today. We launched at the keynote, and I want to tell you a quick story about this. We started with this project about 7 months ago. We had nothing. And within 7 months, we built hardware, we built a software stack, we committed, and today we're launching. So from concept to launch in 7 months. And we're going to FCS this product in April, by the end of April this year, and then GA after that. So let us dive right into the overview. So if you look over here, we are basically infusing security into the data center fabric. Data center fabric has typically been a networking stack only, but now with security integrated natively, it'll be a native capability of the data center fabric. So to do that, we're introducing the Cisco Nexus 9300 Smart Switch family. We're looking at two products to start with, two platforms. The first one is a 24-port 100 gig switch. It has the Silicon One as a forwarding chip, and it has 4 AMD DPUs for hardware acceleration offload, and it can do up to 800 gig of services offload throughput. And the second device is the first device is targeted for April 2025 FCS, and then the second one is a top-of-rack switch we're building, and that's targeted for July. And this one will have basically 48 ports of 1025 gig, 6 ports of 400 gig, and 2 ports of 100 gig. It has Silicon One E100 version and the 2 AMD Giglio DPUs. So with that, the service we will integrate into the DPUs will be Hypershield, and Hypershield will provide layer 4 zone-based segmentation and some other advanced capabilities that we will get into in the later part of the presentation. And we're targeting 4 use cases in this calendar year 25. The first one is Cloud Edge for cloud on-ramp and off-ramp for hybrid cloud connectivity. The second use case is zone-based segmentation. If you have a data center fabric, to give you a zone-based firewall capability. And then the third use case is data center interconnect. So if you're trying to connect 2 private clouds, DC1 and DC2, you can use these platforms for the firewalling between 2 data centers. Then in the summer, we're going to launch top-of-rack use case. That's the second half calendar year this year. And both of these switches will perform as the top-of-rack switches. The first one will be 100 gig top-of-rack. The second one will be 1025 gig top-of-rack. So if you look under the hood, what we have is really the best of class. We have the first one is the Silicon One, which performs the best. E100 is optimized for data center use case, and it performs the data center networking, with Nexus OS capabilities. And then we have the AMD DPU, which we're using to provide offload services. The security offload is done by Hypershield, and we'll get into the details of that in the subsequent slides. So if you look at the smart switch, if you look at from a topological perspective, how the connectivity works, what is the benefit we're bringing to customers? One of the main benefits is device convergence. So typically before, today, if you have a data center switch, the external firewalls are attached this way to the ports. So over here, you have one switch with 4 firewalls, for example. And those are like 5 devices. We can consolidate that into a single platform, a single switch. The forwarding is done by the Silicon One. Each DPU can be modeled as a firewall, okay, or doing layer 4 segmentation. So let's go over the packet flow. So how does the basic packet flow look like? So over here, I'm showing a VRF, a layer 3 VRF that is basically carrying application traffic. And we want to give this VRF a stateful firewalling capability. So step one is basically traffic comes in into the network processor, which is the Silicon One. In the network processor, we will look at the incoming traffic and do a routing lookup and derive the VRF. And then we will know, okay, it is VRF1. And then over here, we will have a policy that will say, hey, VRF1, we want to redirect it to, pin it to DPU1. So we'll send the traffic to DPU1. In the DPU1, we'll have a firewall. Hypershield will have a layer 4 segmentation policy. It'll do the segmentation, it'll do the filtering of the packet, firewalling, and then it will return the traffic back to the Silicon One. And then once the Silicon One gets it, it will do a egress, it will do a regular switching lookup, and then send it out to the right egress port, where you have the routing adjacency. So that's the basic packet flow. It's very straightforward, everything is in line. Now from a troubleshooting workflows.
Question?
Sure.
Previous slide. Does it work irrelevant of what kind of fabric you have, whether it's VXLAN, ACI?
So today this is, we'll go over each fabric type in the use case section.
I could rewrite an EPG, for example.
So for example, initially this is targeted for Nexus fabrics, but you can use this in a ACI fabric in 2 use cases. One is a zone-based firewall and a cloud edge. Okay? So right now, this is targeted for NXOS fabric type, but that is a use case 4. We'll get into that.
Pity.
Okay. But there's a plan for ACI, but that is it's kind of a little bit in the future. So now, if you look over here from a troubleshooting workflow, what we came up with is also now you have 2 capabilities merged into one device. So we need kind of some new capabilities to do troubleshooting, across 2 domains, 2 functions. So what we came up with is a packet flow tracer. The packet flow tracer is a 5-tuple tracer. You can give a 5-tuple flow, and then you can launch the packet tracer, and it will go along the entire path. And what it will do is it will collect data like traffic stats, state, all these things, health information of that flow. From the routing side, it goes into DPU, looks at the DPU, firewalling capabilities, what's going on over there. Takes that information, appends it into the payload, and then comes on the egress, and then does the egress appending, and then it gives to the you can do this in the CLI or in the Nexus dashboard, for troubleshooting. And then the second thing is we also have a packet capture capability that we're building that you can do the packet capture on the ingress of the NPU, egress of the NPU, or in the DPU as well, or from a troubleshooting standpoint. So these are basic tools we're building to support customer deployments. Now I'll hand it over to Jacob to cover Hypershield.
So my name is Jacob Rapp, and I lead product management for Hypershield. So I'll go over a little bit about Hypershield and how it relates to the Nexus Smart Switch that we are building. So first of all, I think Java is going to cover a bit more in some of the use cases of how we're actually melting some of the security into the network itself. And there's a lot of just this operational simplicity and actually combining, not having to hairpin traffic through these zone-based firewalls anymore by actually building into the network fabric itself. So we'll go over some of those use cases and how that makes operational simplicity a lot better for customers. But for Hypershield perspective, I wanted to quickly go over some of the more advanced security use cases that we get out of Hypershield plus the smart switches. A couple of them obviously is kind of, if you think about change with security, change is some of the most risky parts of security. When I'm going and making some broad changes to my zone-based firewall policy, or I'm just updating kind of more granular micro type segmentation policies, or I'm just updating code. These all tend to happen in these big change windows on a weekend, on a holiday when someone really doesn't want to be on call, but they're on call because there's this big change happening. Can we simplify security a bit more as we start to melt it into the network? And at the same time, can we make even security better? So Java mentioned we're starting with layer 4 zone-based segmentation. But where do we think about how layer 7 moves in the future in the data center? And how do we actually keep up with that security when encryption becomes really pervasive across your entire data center? Doing layer 7 stuff on the network starts to become harder and harder. So where do those controls shift? Do we need a new set of controls to work alongside our segmentation controls moving forward? That's all kind of pieces that we're trying to solve with bringing Hypershield as the first service within the Smart Switch. So just a recap of Hypershield. I'll just go over this quickly. We launched this last year, but we've been working with a lot of different customers on bringing our enforcement points and helping customers with their security problems. The first thing we were doing when we built the Hypershield, when we talked to customers, they said, don't build another product. You need to fix and kind of combine the outcomes into a single solution. So we talked about security cloud control this morning. I think G2 was up on stage kind of talking about the whole broad security cloud control vision that we're bringing together. So we actually started to build a whole platform. So think of this as their AWS console for security services. So this is where all of our security services will start to come. And within that, Hypershield provides a number of outcomes. Last year, we launched autonomous segmentation, which we'll start to bring into the Smart Switch as well. Distributed exploit protection, and now we're bringing the layer 4 zone-based segmentation policies within the Smart Switches itself. With that, we have a number of enforcement points within Hypershield that work together. They're not disjointed enforcement points. We have enforcement points directly within the kernel of the workload. So if you think about like what was traditional layer 7 policy within, say, a traditional firewall, you have things like layer 7 app IDs.
There a reason why Windows says soon? Very, very little.
Yes, yeah.
As well as VM appliance. Yes. Which VM appliance? What?
Yes, yeah, absolutely. So in the workload, we use a technology called eBPF, or Extended Berkeley Packet Filter. That was a way at kind of bringing controls sanctioned inside the kernel. It started in the Linux community, and it's been around for about a decade, but it takes about a good decade for those types of technologies to mature. And it's kind of like the idea of it is like, can I have sanction controls inside the kernel that are delivered by Linux or Microsoft directly? So it's not a kernel module, because there's lots of issues with, if I write a bug in a kernel module, we all know what happens. It could cause very bad things to happen. So eBPF is sanctioned by the community. There's a verifier before anything gets put into the kernel. There's lots of checks around making sure we don't have infinite loops or memory out of bound conditions, a bunch of things to get into the kernel. So that started in Linux, but we're working with Microsoft on bringing that to the Windows world. There was already an add-on to Microsoft, to Windows previously, but now this is kind of the next gen solution. And I think at some of the KubeCons that the Isovalent team have presented some of that work that we're working on jointly with them. So that's why our Windows is saying soon, because that work is in progress on the Windows side. The VM appliance is basically a virtual form factor of the Smart Switch as well. Yeah, go ahead.
What other kernels, like kernel?
So right now we're focused on more of the data center side, and not the end user compute.
There are plenty of BSD-based appliances out there being used in enterprise data center world as well.
Yeah.
You want to have eBPF all over the place.
Yes, absolutely. Yeah, I think that's the long-term strategy, is to start to make it pervasive as well. But I think in terms of enforcement points, if you look at security cloud control, we also support the secure workload, where we can also tap into IP tables, Windows Firewall, and other aspects of the stack where eBPF may not be ready yet for all the enforcement. So that's the good part about having security cloud control kind of being on top and managing the rest of the endpoints.
And for Windows, so there's on eBPF on the website something for Server 2019. So will not be all Windows operating system with different code, will be 2000.
Yeah, it'll be TBD from Microsoft, because ultimately Microsoft controls the release of eBPF.
And the Hypershield ideas at the end of the day, the new, let's say, Cisco switches that are having the DPUs and this enforcement, you can put the same controls, like your controls could stretch over the old workload enforcement over the new devices, and you have kind of a unified policy layer that you stretch across these, yeah?
Exactly. Yeah, perfect segue into the next piece. Well, we can hop back into the architecture side as well, and as we go. But yeah, that's the whole idea, is we have a single intent-based policy that you write your intent at the top, and then we can take care of compiling it to the right enforcement point. It's order dependent, and we take care of policy placement, because our thought process is at scale across infused in the network or at every single workload, no human can actually try to figure out where to place the policy. So we take care of that policy placement engine. A good example of a policy that I use that may span both. Let's just say I want to write a policy that blocks all web servers from being jump hosts. I want to be able to SSH in or kind of access the web server, but I shouldn't be able to SSH out. So from a policy perspective, you can write that on a single policy layer up here, but we may translate it in two different places. With an eBPF, say at the very top, if I have the eBPF components, I'm able to actually write a policy that blocks SSH from opening a socket. It's not flow table, it's not blocking a port and protocol. It's actually saying SSH cannot open a socket to any destination, but it can accept connections. But I may also want to apply that as a guardrail policy still on the network, where on the DPUs, I set the policy and match all the IPs of web servers and still block the port ranges for SSH there as a guardrail that catches any of the other workloads, as well as just having a hardware separation of security policies still.
And from a scalability perspective, have you tested how much policy can you put on the new DPOs? What is kind of still in the supported range?
Yeah, we're working on the final numbers, so we haven't published the numbers yet, but it's will be at a fairly impressive range because essentially the DPU is, for all intents and purposes, a firewall. So you're not going to run into like TCAM limitations or things like that. It'll be in a very large scale roles, and all the customers we're working with early on across financial industries or healthcare, even some service providers, the scale numbers they expect are fairly large, but we haven't published them yet.
So not a 3-digit number, more a 4-digit number, yeah?
It'll be a pretty large number.
Okay, good.
On
Yes.
policy enforcement, like blocking an SSH opening a socket,
Yes.
what if I would use a pervasive technology like, easy, rename SSH to whatever process I want to rename and then open the socket?
No, because ultimately if I go kind of one step deeper into the enforcement point, right? So eBPF is natively within the workload itself. You need a control path to eBPF. So we use an agent called Tesseract Security Agent. It's super lightweight compared to most agents out there. We actually underneath the hood, we're using an open source project called Tetragon, which was developed by Isovalent, which we acquired last year. So all the core is open source. That's super important to customers is to have like an open source core for what we're building. Here we can actually start to profile the processes. So number one, yes, you can match on the process name, but we can also match on the process hashes, or we can actually start to see processes being renamed to something different. Part of our autonomous segmentation, which we can cover in a different session. I want to focus more on the DPU switches. We can kind of actually start to look for deviations and profile different changes as anomalous and protect against those as well. But there's a lot of work we're doing inside here from an autonomous segmentation standpoint. But those work alongside our other network enforcement points as part of it.
You can go back 2 slides. What is meant by AI native security?
Perfect.
What is the base
Yes.
security?
Absolutely.
AI.
Yeah, so immediately everyone thinks of AI, they think of large language models, and like we're going to send all the customer data to some model, and customers get freaked out over that possibility or scared of that possibility in general. What I mean by AI native isn't that. We are using large language models to generate compensating controls and some really interesting work behind there. But what we mean by AI native is actually, how do I make sure that anything in AI, if I have my own AI model as a customer and I want to use this system to roll out changes in an automated fashion, what do I have for checks and balances in the architecture? So that goes along the idea of this self-qualifying updates. So these kind of two go hand in hand. AI native means that I have a system that can actually test in real time the assumptions that AI makes. So we do that with what we call our digital twin technology. And digital twins come in a couple different form factors. The form factor for the DPU switch is with what we call a dual data plane architecture. So if I go to this next slide here, we are implementing what we call a dual data plane in every one of our enforcement points. That is a network enforcer. So in the VM appliance, which is just a VM version of the DPU switch, think of it as like a virtual firewall.
I do want to get back to that because so is that VMware? Is that KVM? What?
Yeah, so we can bundle lots of different ways. We can bundle as a container, an OVA, and an AMI for an AWS. So it's just a general purpose like software firewall that we can bundle and use in different places where you don't have the ability to place the new hardware pieces at. But again, you'll be constrained to kind of the same issues of any VM appliance. It's just not as scalable as what we can do by building into the network.
you're not integrated into whatever, you're just going to provide an OVA or something.
Yeah, so if you want to go fully in, like deep within the kernel, that's where the eBPF controls get you. But this is kind of, well, if I go back to this slide here, those are the two form factors. Network Enforcer is kind of like outside the workload. VM Workload Enforcer is kind of the inside view as part of that. But if I go back to the dual data plane architecture, this is kind of where I get to the AI native, is that we build those digital twins as a dual processing pipeline in every single one of our enforcement points. So in the DPU switch, we have the pipeline built into our fast path, where we do parallel processing of every policy statement that's being made. We're not actually duplicating the traffic because we utilize some shared memory and some really interesting tricks that our developers came up with. That we're not like having the bandwidth or something like that. That's the first question that usually comes up. But we're able to like run a parallel pipeline for all of the different policy statements. So we're starting with policy, and then we'll start to bring that also to all of our different software components too. So can I upgrade my software on the dual data plane and then test it in real time across all of the different enforcement points before I start to then promote it and do kind of a canary blue-green deployment scenario when with my policy or my the software upgrade. And that's kind of the goal of like, how do I make security operations better and make change normal as a normal activity? So when I have AI, the LLM versions of AI trying to recommend policies, changes, you have a really good way to test it and validate those changes aren't going to break something or don't have a effect that you didn't intend because of the model or something doing something you weren't expecting. So with that, I'll give kind of a couple examples of this, and we can keep rolling through. This is the policy testing version. So this is working today. This is something we've had for a while from the VM appliance form factor, where our policy framework that we use, and Mauricio is going to talk a bit more about what that policy framework starts to look like. What we have is active drafts and history. We kind of follow somewhat of a GitHub methodology, where active is kind of your main branch where everything is in production on. Drafts are when you want to make changes. You basically check out a version of that policy or software and say, okay, in the drafts, I'm going to make changes in my drafts. And then before I promote my drafts to back and merge in the main branch, it goes through a testing cycle. And when it starts testing, it actually starts to test that policy group across all of the infrastructure where that policy needs to apply. And then finally, it'll give you a confidence score and a bunch of results around the policy. And it covers a bunch of results such as just CPU, memory, latency metrics. It also, I didn't take the rest of it. There's flow, there's hit counts for the rules, and so on. So we're able to actually reason about what those policy changes are and give you kind of a confidence score when we go change a policy or do a software upgrade.
So it's a little bit like a beta release or something.
Yeah, pretty much. Yeah, draft is kind of like a beta release. So I'm going to try it out in my shadow data plane before it hits production. And if I want to do a rolling production upgrade, you can do that with that.
Is it possible to do a for I principle changes?
For I principle?
Yeah, so that there are two folks checking and validating that these are valid changes. For the little bit more high secure environments or high operational environments, you want to have a double human check to know for sure that this is actually a violation of anything else.
Yeah, absolutely. I think those are kind of the next steps. It's like we don't do anything autonomous at this point where there's always a human check. And that's kind of where there's like, my confidence score is probably never going to be 100. There's always at some point, like there's a human review process that goes into this, especially for like large like drops or changes in flows, where I may be doing exactly the intent you said, but I may be doing that and dropping a very critical application. So I always want to have someone checking and understanding that. And then as G2 announced, I think Tom announced as well this morning, we have a universal AI assistant that can also, we're thinking about like how do we use that to auto-generate like your draft of like why this change is acceptable. So it's like the big part of policy change isn't just the, hey, is it working okay? It's the let's have an audit trail along the way, every step along the way, to prove to the auditors and everyone else in compliance that this change is acceptable and meeting the intent that you had for it. So that's, I think, where our AI agent and our universal AI assistant will help quite a bit.
I have a question for that. A pain point in traditional firewalling was often the deployment time. Yeah, somebody, it's nice you have this, you deploy it, you see, oh, it's breaking. People cannot work anymore. Then it takes, I don't know, 15, half an hour to roll back. How fast is policy updates happening in this system? If you need to roll back something or so.
It's instantaneous. So I can, in my dual data plane, I can
So you just flip them, right?
flip them because they're both active 100% of the time. And just at the end of this one, I choose to use the primary's result versus the
So that's why you have the shadow one. So you can simply enable the shadow one just in case.
Yeah, so if I switch my primary to my shadow, then my shadow still remains, the primary still remains using the old version. So if I ever want to roll back, it's just a matter of like saying, okay, use this one evaluation versus this evaluation.
Okay. So,
The DPU is in this case already programmed for both.
Yes.
This is why you can flip so fast.
Yes.
But if I need to roll back even to something else, then it will take longer, or what is there the policy?
Yeah, it's just a matter of like how can I I can keep track of my changes. So if you look at back here, we do have a history of everything that I can go back in time to add those to. We would probably go through the testing cycle again.
so probably
to
what you
validate
would
that.
do is look at the one of the changes that is in the history, and then you probably then deploy it on the other data plane that you have there in parallel, and then you'll switch over to that one. So you would always go from one data plane to another, and then putting a different version of the policy, right?
Yeah, exactly. Yep. Yeah, and then we would just kind of load the policy on the shadow.
Yeah, it's
again,
make
and
before break.
Yeah, exactly. Yeah, but there's lots of interesting options that we can do, and that's really the goal of making change normal, so we can test. I know I'm running over my time, so I wanted to make sure we hop into the use cases and cover the DPU use cases of where we feel like this is the first entry point for customers for the smart switches.
Okay, so we'll cover the use cases now. So the first use case is the Cloud Edge use case. So this is for cloud on-ramp and off-ramp. So typically, if you look over here, this is your private cloud. This is your public cloud on the right, on that side. And then in the middle, we have the Cloud Edge colo site over here. Now, the thing is typically, what we're saying is typically before the smart switch, the DMZ, this is the DMZ. And the DMZ for hybrid cloud connectivity today from public to private cloud, the firewalling is all done in the DMZ today. And the DMZ is a single point of failure for customers. And this is not something Cisco came up with. This is all our customers are telling us. Actually, there's some of the largest banks in the world, in US, Europe, and Asia. We work with them, and we were looking at the DPU, the smart switch, how to use that with Hypershield. This is use cases. This is a use case came from customers. What they are telling us is the DMZ is a single point of failure. Today, it's very inflexible. From a routing standpoint, you cannot do optimal routing from a public cloud VM to a on-prem data center VM. You have to do traffic engineering. You have to force the traffic into the DMZ, and then it gets firewalled, and then you have to trombone the traffic to the different data centers. So one is routing complexity. Second thing is, in the data center, you can only buy big iron firewalls and scale up. You cannot horizontally scale out. That's two. Number three is it's very expensive. Those are very powerful, very expensive multi-ASIC devices. And then they also have a high, because the firewalling part works perfectly, but that is maybe 30% of the actual work you do is configuring firewall policies. But 70% is you're managing the life cycle of those big iron devices, upgrading them, getting maintenance windows. So what we came up with is a simple solution. We can solve that by putting the Cisco Smart Switches over here with Hypershield, doing layer 4 segmentation right here. From the public cloud, you can terminate the direct connect and express routes directly over here with the MACsec tunnel, with MACsec on those tunnels. And then we do firewalling first. The first thing we do is firewalling, and then we do routing directly to the data center, bypassing the DMZ. So that's the use case of Cloud Edge. And this is basically a NNI to NNI, So this is a first use case we are launching in April, okay? And this use case can be used for all any data center fabric types. On the on-prem, you can have Cisco data centers, you can have a ACI data center, you can have a Nexus data center, or you can even have a third-party data center, okay? So the second use case is zone-based firewall. So if you have, let's say, a ACI fabric or a Nexus fabric, you'll have, let's say, two tenants. You have tenant prod, you have tenant dev, and for inter-tenant communication, it all typically goes through a zone-based stateful firewall. So what we're saying is, instead of buying a very expensive firewall, you can drop in one pair of smart switches with Hypershield on it, an HA pair, and you can drop that in, and we can offer the same segmentation that you're doing today with a very high-end, very expensive device at a fraction of the cost. So that's use case 2. This use case, when you deploy this on the fabric side, if you have ACI, you have a service graph, there's no change in the configuration. If you have Nexus data center or even a competitive data center, there's no change. You just drop this in, and then you do a L3 connectivity. That's it, okay? So this is the second use case. The third use case is the data center interconnect. If you have two data centers, let's say this is in Amsterdam, that your remote data center is in Belgium somewhere, and all the incoming traffic on the border leaves over here will get inspected, will get filtered first, and then it gets routed into the data center. So that's use case 3. Okay, so these are the 3 use cases we will launch in April. Now, the fourth use case is the top-of-rack segmentation and enforcement. This is what we're going to launch in second half calendar year 25. Now, for this one, we will have both the 2 switches that we have, the 100 gig and the 25 gig will be used for this position. And they will play the role of leaf as well as a border leaf. Now, over here, the benefit is every device in the, every leaf becomes a firewall port in your data center fabric. So you can do stateful rules synchronization across all your data center leaves. So the data center leaf becomes a firewall, a stateful firewall for you, right? So we're starting this one with Nexus first, and then we will, ACI is in the future for us. Okay?
So this is kind of solving the problem. I have appliances or devices that I cannot influence. They have maybe vulnerabilities, whatever. I have a small firewall that already sits on this port in the network up front this, let's say, unsecured device, and I can apply policy, do all these nice, let's say, telemetry for the devices, even if this is an appliance where I couldn't implement, let's say, eBPF natively on kernel land. Yeah.
Yes. So to extend that further, if I borrow, I also work on ACI. If I use the ACI model, right, over here, like how we used to explain ACI, ACI normalizes micro-segmentation for container workloads, VMs, and bare metal servers, and even mainframes, right? So if you have a Kubernetes workload that you cannot have an agent, a Tesseract agent on, or you have a VM, you can do PVLAN all the way here, and we can, for all workloads, we can consistently give you a policy, and stateful policy. And what you can remove is if you have agents like Illumio agent or Guardicore or different probes, the telemetry probes, or virtual firewall or physical firewall, you can start removing those things. Now, we are not saying you'll remove 100% of those, but you can start reducing. So you have less dashboards to go to and less things you have to manage.
I think the other benefit here is clear. All these agents suck up CPU time, maybe we have additional delays and so on. If this is programmed to the DPU, it's kind of line rate.
It's line rate.
Yeah.
It's a P4 fast path pipeline. But I want to add to the point that, very important point Jacob made. The Tesseract agent, it's a very lightweight agent that is like an orchestrator of eBPF.
So at the end of the day, the same methodology, the same EPF code just runs on the DPU. So you just made all the crafting that normally is done on the, let's say, operating system level into the network. And then you have kind of a faster, let's say, line rate thing without having anything on the end host system, which influences the performance stats. Yeah.
Yeah. So when you compile the policy, right, from security cloud control, when it goes to the workload, it is compiled as a eBPF policy. When it goes to the switch, it is compiled as a park policy, which is something we will discuss later in the slides.
It's more difficult. It's going to have the exact same. Not going to have the exact same.
Of course. Services you cannot do, yeah.
You can't do process level on the switch, right?
Yeah, makes sense.
Okay, let's continue. So this is just a kind of showing you a side-by-side comparison. Today, typically in our Cloud Edge example, you have two switches facing the public cloud, two switches facing the private cloud, and then you have a firewall pair. So you have 6 boxes. We can replace that with 2 boxes, HA pair. So that's a consolidation, cost saving, less devices you manage. It's good. You remove things you don't need. So let's get into the workflow. One of the things is, now since we have one motherboard, we have 2 ASIC, 2 chips. One is a network chip, one is a security chip. We're doing security. How does your operational model change? So like a large bank, they will have a network team and a security team. So what we were extremely careful is we carry that forward, that persona-based workflows that exist. We do not want to change that. We don't want customers to adapt to this. We adapt to the customer from the day one. So what we've done is we have full separation. The network team does network things, security team does security things. So for example, you can use Nexus Dashboard to program, will manage the lifecycle of the switch, okay? You'll have single OS it will install, and then there's a network policy it will push. And that's the job of the network admin. And then the security admin will go to security cloud control, and he or she will push the security down into the DPU and for rendering. So that's the separation we have. It's full isolation, full RBAC. So we carry that forward. So I'll hand it over to Jacob, and then I will cover.
Cool. All right. Yeah. So yeah, I think what Java's mentioned is like it's important to keep kind of the separation of controls for the teams to kind of operate independently of this. So if I think about how we start to onboard the switches and how we start to use them from day one, obviously we have the single image, so we can bring up the system. It has both the Hypershield bits, control plane bits, as well as the NXOS bits there up and running. What you do over here is request a token from Security Cloud Control. Apply that token so that the agent can then talk home to the Security Cloud Control. From there, we can configure the VRFs and what VRFs you want to enable the service firewall policies on. And then finally, you start to configure your objects and your policies within Security Cloud Control. So it's a pretty simple, straightforward workflow. We can automate it through APIs. Everything's API first. So if customers want to bulk onboard, all of these things are possible. You don't have to do it through the UI as part of the framework.
Is it possible to run Security Cloud Control on-prem for digital sovereignty?
No.
Similar to Intersight, which you can do on dark sites?
No, Security Cloud Control is a SaaS-only option. So yeah, so customers that will want to do this will have to adopt SaaS methodology. So it's not really for the air-gapped like deployments.
No digital sovereignty there.
Yep. Yeah. I think we are working through. I mean, a lot of customers have. Some of the customers have concern over that. So we're pretty open about our architecture and how we can kind of work through passing tech risk audits and those types of things to get this up and running. We're doing that with a set of customers right now, especially in like the financial sector and some of the service provider sectors are like sometimes they're nervous about having controls in SaaS. So there's a lot of thought around that architecture we put in and to validate with them for it. So what that looks like in the product is we have the 2 types of network enforcers in Hypershield, the VM appliance and then the Cisco Smart Switch. Here, when you want to add a Cisco Smart Switch, we can generate a special token, and Mauricio, when he does a demo, he'll walk through how to apply these commands onto the Nexus switch. But this is basically the token that we would generate that you would be used to onboard the switch. Here is showing a view once they're connected. Once I do this, I would have a pending state until actually you apply those commands on the Nexus switch. It inherits the host name of the switch, so you can kind of match which switches are available within the Hypershield control. for the security parts. And then here we just show which DPUs are active across which VRFs for this. So you'll notice here there's some static and dynamic pinning. Mauricio will go over what the differences of static versus dynamic, but here's kind of a way to figure out how to share load between the DPUs, because the first switch has 4 DPUs on them. So we can kind of share balanced load, either statically assign it or dynamically assign it. But Mauricio, as it goes through the demo walkthrough, will go into some more detail there. So with that, I'll hand it over to Javed to walk through kind of the persona side.
Yeah. The couple of things Jacob said, I want to recap. Like the token generation, onboarding of the switch, how do you integrate? So all that workflow will be between Nexus dashboard and security cloud control. They will talk with each other east-west way. So I'm just going to show you the actual automation and insights and troubleshooting. So over here in the Nexus dashboard, we'll have an automation workflow. So what I want to accomplish is I want to redirect a VRF to a DPU. How does it look like? So the first thing is I will select 2 Azure VRFs over here, Azure VRF 1 and VRF 2. Then what I'll do is I will select the DPU switches, and I will also select the DPUs where I want to pin these VRFs to. I want these Azure VRF 1 and 2 only go to DPU 1, okay, in both switches. So when I do that, then I'll get a kind of a configuration, so I can check if the configuration is correct. So once I'm good with that, I'll say push, deploy, and it is deployed. So you'll see the redirect policy from the VRF to the DPU is provisioned. Now this is a UI workflow. You can use UI or API, both are options for the network team. So over here, this is insights. So what we've built in the Nexus dashboard is the full insights of the DPU switch. So this is the DPU. If you go further, I had to cut it out because of the slide for the footprint. There's a lot of operational details, stats, and all those things available. So on this DPU, I have 15 ports enabled. But what I see is some anomaly. Now the system, the Nexus dashboard will automatically detect those anomalies and give you the summary. So if you click it, what you will see is this type of view. So over here, I have a Azure VRF 2 that is in a leaf and spine fabric, in a Layer 3 BGP leaf spine fabric over here. And this is the DPU switch. But the NPU is sending traffic to the DPU, but when the traffic is coming back, there's something wrong with the traffic. And it has nothing to do with the firewall policy. It's something else, it's dropping. So when that situation happens, the Nexus dashboard will go to this level of granularity. It will identify where the root cause is. So once you get down to that, if you want to do the further analysis, you can trigger the packet tracer that we discussed earlier. That will go from NPU to DPU, and it'll give you it'll come back and give you the root cause. Okay, so that is the level of automation we have. So with that, I'll hand it over to Mauricio.
Okay, so yeah, I'm gonna show you what we have now in terms of based on an NFT image, early field trial image. But before doing that, let me just recap on a couple of things to understand what we're showing. So this is how a simplified view of the architecture of this switch. And the configuration Javed showed you, last one, was based on the Nexus dashboard. All the configurations in the demos are based on the CLI for the network configurations. And for the security policies, they're based on Hypershield. So security policy, who is allowed to talk to what, is based on Hypershield. Which traffic is sent to the DPU for inspection is based on the CLI configuration, okay? So yes, so for the configuration, you go to the Hypershield controller in the cloud. It's going to talk over HTTPS to the Smart Switch. But for that to happen, the first phase of the demo is going to be how to make the switch discovered by the controller. Okay, so there's the onboarding of the switch into the controller. And once we are in the controller, we define the policies based on this language, which is, I mean, in the end, it's going to be source IP, destination IP, layer 4 ports. but the language that Hypershield provides to define policies is more, it covers more cases than just IP addresses, right? And so it's based on the syntax that is called park. Principal is the source IP, basically, in our case. So if we compile this to the DPU switch, principal becomes a source IP address, okay? Resource becomes a destination IP address. Actions, basically, if it's like the eBPF process, will be like if a process can read or write. In the case of the DPU switch, this becomes the layer 4 ports and protocols. Okay, so basically what you want to do on the resource. You want to access certain ports. Effect is the permit deny, permit plus log, deny plus log, and so on. Okay, so Hypershield has this language which is very broad, but in the case of the demo, you will see that it basically allows us to define an ACL, a stateful ACL, but an ACL. Okay. Now, so the first phase is, I was saying, the onboarding, but there's another key point, which is first you need to power up the firewall. You need to power up the DPU. So once you get this Nexus 9K switch, if you use it right away, it's basically an XOS device. So you can do routing, you can do routing protocols, and so on. And so the traffic will just flow through the network processing unit, like a classic XOS device. To get the traffic to go to the DPU, the first thing you need to do is to power up the DPU, and you power it up by using this command, feature service acceleration. Okay, so you can also think of these devices, device with two possible use cases. One is just like a classic Nexus switching device, and the other one is like a switch plus firewalls. Once you power up the firewalls, the next step is to assign certain traffic to the DPU for processing. And in the first release, excuse me, this is going to be based on VRFs. So one VRF is serviced by one DPU. Not all VRFs need to be going through the DPU. You could have VRFs that are not requiring any extra filtering capabilities. There are the VRFs that are connected maybe to the cloud, for which you want to provide security services, and then you will want to assign them to a DPU. And you can either let an XOS distribute the VRFs automatically to DPUs, or you can manually define which VRF belongs to which DPU. And this is the syntax that you can use to assign them manually. And that's for the first release. Of course, when we move forward, there will be other options that are not yet displayed here. Okay. And then you can verify what traffic, how much traffic is flowing through the DPU by looking at the counters of this special interface, which is a 200 gig interface, which is visible as service Ethernet. So with 4 DPUs, you have service Ethernet 1, 2, 3, and 4. And you can look at the counters and look if the interface is up and so on. So this is the internal link between the switch and the DPU, as if this was, if it was an external firewall, you will look at physical interface on the front panel ports. In this case, it's all internal to the switch. Okay, so now we have here the steps that you would take on Hypershield to define the policy. So first you see network-based enforcer, because the switch is a network-based enforcer. Then to define the source and destination IPs, you would define objects. So here you have the clients, which is this IP range, and servers, this other IP range. Then you would create the policy and decide if traffic is allowed or dropped, and whether it should raise a log or not. And once you've done with that, as Jacob was describing, you would run a test, and then after the test results, if you're happy with it, you can deploy to the switch. The test consists in having copies of the traffic going through the new policy, so that you can compare the hit count on the shadow data plane compared to the main data plane. That's visualization that Jacob was already showing. And if you have new rules that were not there before, then the number of hits on the primary data plane is not applicable because it's a new rule, and then you would check the number of hits on the shadow data plane for the new for the new rule. Once you're happy with the results, you can then deploy, and this will be applied to the data plane. Okay. Okay, so with all being said, now we're gonna see the recording of a lab demo that is based on an early field trial image. So certain things you see here are actually gonna be improved. Just you have some visualization that were already provided by Jacob and by Javed. But certain things here look a bit engineering level, but that's because it's an early field trial image, okay? So, so first part is going to be to enable the DPU. So you have this command, feature service acceleration, that powered up the DPU. And then the first phase of the configuration consists in onboarding the switch on Hypershield. To do that, we're going to say that the switch is going to connect through this interface, which is loopback 100. This is an existing switch that is already connected. Ours is not yet. So the first thing we need to do to make it show up here under the network enforcer in Hypershield is to get a token, which we're going to get a one-time password, basically. So this is going to be integrated into Hypershield. Okay, for now, as you can see, it's basically REST calls, but it's going to be integrated as part of Hypershield. And the token has all the information that the switch requires to connect to the controller in the cloud. Okay, so we need to take that token, and that token gets, so for now we just see that as a pending connection after you generate the token, because Hypershield is waiting for this switch to show up. So what we need to do is to take that, go to the NXOS CLI, enter the token, and then the switch is going to connect to the cloud, and it's going to show up into the Hypershield controller. So now we're entering here the token.
The requirement here,
You need to
connection to the cloud, to these, let's say, cloud backend URLs must be,
yes,
is mandatory, okay.
yes, or either directly or through a proxy. The proxy is not yet in the EFT image, but through a proxy is also possible.
And you just need 443 or anything else for the cloud?
It's basically SSL traffic, okay? But there are a couple of ports, and we're listing them in the documentation that you need to open to let the gRPC to work through, yeah.
And where is the cloud? So is that?
The cloud is, I think we have, do you know, Jack?
So we have multiple regions throughout the world, basically, and all multi-availability zones and so on. But yeah, you have to be able to allow list a certain connections to that in order for it to connect up. But again, if you have proxy, you can have just a single connection and not have to have every single switch connect through independently.
And these clouds run dual stack completely. So IPv6 enabled native.
Yeah, v6 will be there. Yeah.
Will be there or is there?
I mean, well, the EFT image is v4, but it will be there when we FCS.
Okay, so here we have put the configuration in place. Okay, so now what we're going to see is, so we put everything in service under the service, there's the system service Hypershield. And then here we had, oh, I think we're back to, okay, anyway, so yeah, so it's onboarded. Now we're defining the security policies, okay? So we're defining the objects, like you saw in the screenshots before. So here we're defining actually the resources, and you're just gonna put an IP any, okay? And this is defined as part of what's called a policy group, which is just the configuration container for the policies. And this is going to be then pushed to the DPU switch, okay? Okay. So this is just going to be permitted. The action is defined as TCP ports. So TCP, UDP, ICMP is all going to be selected to allow all the traffic. Okay. And since we're a bit short on time, let me get to the data plane, if you don't mind, so that you can see traffic forwarding happening, because otherwise we don't So this is the configuration of the policy. And now we're going to check the data plane part. So we have the switch, which is pairing with BGP on the cloud, and it's pairing with ISIS with internal network. This is the view of the DPUs, okay? But now I'm gonna show you that we have BGP peering in place, we have ISIS peering in place, and then we're gonna send traffic. And in the first test, we're gonna make the traffic just go through the MPU and bypassing the DPU. And the second part of the test, I'm gonna show you that the traffic is actually going through the DPU, okay? So the VRF you're gonna use is this one, OCI1. And in the first test, I'm removing it because I'm just gonna show you that traffic is just flowing through the MPU. Here on the traffic generator, we are enabling BGP and ISIS to peer with the device, and then I'm gonna send routed traffic across. So if we now look at the configuration on the VRF, you will see that we have two interfaces there in place for the VRF, and so 1.4 and 1.18, and you will see in the first example that the counters for those interfaces will be increasing. Here you can see that BGP is working, ISIS is also working, so all the control plane stuff is basically in place. So we have adjacencies for ISIS and BGP. Okay. Now the counters are still 0, and then we're gonna start the traffic generator, and then we're gonna see that the counters are gonna be increasing only on the interfaces that belong to the MPU and not to the service Ethernet interfaces yet, okay? Because the VRF that we're gonna use for the DPU is not in the config right now. It's not into the, it's not assigned to the DPU yet. So here we start the traffic. It's gonna send 1,000 packets per second. And we're gonna see that the counters are gonna be increasing. Let me just, we have 1 minute, okay. So if we look at the counters, you see that these ones will stay 0, but the counters for the interfaces that are connected to the BGP and ISIS cloud, they're increasing. And so you see 1,000 frames received from Ethernet 1.4 and going out on Ethernet 1.18. And nothing goes to the DPU. So now we're gonna put the VRF, we're gonna assign the VRF to the DPU. And then we're gonna see that the interface counters for the DPU are gonna be increasing. Okay, so, okay, now we go back to service firewall, we enter there VRF OCI1. Okay. You can either, you don't have to type this. In this case, we assign it specifically to DPU number 1. So now you see that the VRF is back to where it's supposed to be, into the configuration for the Hypershield. And then if we look at the counters, so actually here is the view of the interfaces of the DPU. And again, we have here traffic going in both directions. So you see now the Ethernet 1.4 is both sending and receiving 1,000 frames per second, same for 1.18. And then you have the counters for the interface of the DPU. Now here, the DPU is receiving traffic from both and going down again, right? So this DPU is servicing that VRF. And the traffic is getting back to the traffic generator, which means the whole path is actually functioning, okay? So that's, and so the traffic is indeed going through this firewalling engine, the DPU inspection engine.
Just one thing from my security view on it. This is a very routed approach. From my audit perspective, now I have to check every time, was a policy actually enforced, because I can control on the Nexus, let's say, management layer, if even the traffic goes to the firewall DPU layer. So kind of from an auditing perspective, this is adding another layer I have to check on everything that I verify. Was this at this point in time, this traffic going to this DPU and then the policy enforced, yes, no. So it's kind of adding some complexity. Maybe for some customers, they like the flexibility and the, let's say, separation of duties. But of course, then you have always two things to verify if something is policy.
But wouldn't you have to do the same with an external firewall, because there will be anyway the external interfaces? You would have to, I mean, if you troubleshoot an external firewall, you also have that same level of.
Most people doing like the gateway is always a firewall, then you have just one entity to deal with, or it's on the endpoint, an eBPF perspective. No, it's on the system.
Yeah, I mean, I think you would still have to redirect traffic to the firewall.
Yeah.
In some way, this is just our internal redirection, but point taken, I think in future releases, we're going to have options where it's basically, can I send traffic, make sure all the traffic is going, and then in our dashboard as well in Hypershield,
Exactly.
you can actually see and make sure that VRFs invalidate. But we can work on some enhancing of them.
Auditing logs for these and to make sure at what point in time what traffic was forwarded and is going to the policy or not. Yeah.
Data leaks are digital.
Yeah, exactly.
Does it do correlation though? Because I understand that you could be testing
policies and you could make sure that things are deployed in the way that you expect it. But what if you actually have to investigate? Does it do correlation between the time you place the policy and what were the changes after that and before that?
Well, actually, I think also through Nexus dashboard and the, we have all the tools to basically compare old configs with new configs. So you can leverage all the other management tools that we already have that allow you to verify configurations on the Nexus products already that can do that, right?
Yeah, we'll have full audit logs too on the Hypershield side, because even though we're not configuring the VRF redirection from Hypershield, we'll have the change logs, so we can actually see, okay, this was how VRFs were provisioned and configured, and how they were set to DPUs, and then policy changes alongside that. So we will have a full audit trail there, or you can also obviously send both audit logs to a similar collector for everything as well. Yeah.
For these, you could even leverage Splunk.
Yeah, absolutely.
Isn't it?
Yeah.
Okay, so you can just put all the pieces together and then, well, eventually you would just need a bigger screen, I guess.
Yes.
Okay, good. Thank you.